Hello everyone, welcome to the next lecture on the numerical methods. Today I will explain you the 15 examples related to the error analysis. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the numerical analysis. I hope you can support my efforts by subscribing and liking the video. What is the objective is how we can find the error. It's a very simple lecture. As you all knows, whenever you have a data points of the n plus 1 which is defined in this table, then you can easily define the polynomial px which is of the degree less than equal to n. How you can find the polynomial? That means you can either use the Lagrange interpolation formula, you may use as a Newton's divided difference formula, you may use either as a Newton's forward difference formula, or you may use as a Newton's backward difference formula. All these lecture I have already covered in this. You can see this Lagrange interpolations, Newton divided difference, Newton's forward, Newton backwards, and many more available in this playlist. Kindly subscribe my YouTube channel so that when I uploaded my next video, you will get the notifications. Now you can see the f of x consists of the n plus 1 data points. P of x is a polynomial of degree at most n. Then if you subtract them, you will get the error. And that error will start from the degree n plus 1. What is a pi? Pi I can define as a x minus x naught, x minus x1, x minus xn. The proof of this result I am not explaining in this lecture. You can find this proof already available in this my playlist numerical analysis. Once we know this is the error, we can find the maximum value. How you can find the maximum value? Which is less than or equal to n plus 1 factorial into maximum of the pi x and maximum of the n plus 1th derivative. Make sure student you have to write this formula on your copy so that I use the same formula throughout these 15 examples. Whenever you will see this formula, your objective is only to find the maximum value of this case and the maximum value of the fn plus 1th derivative. Now the question arises, once you find the maximum value, you have to find the maximum value at the given point. Now what is the x star? There are the two cases. One case is when x star is already known to you, and the second case is when x star is unknown to you. When x star is given to you, then you can find the value of the pi directly by substituting the value at x is equal to x star. Otherwise, how you can find the maximum value? You can take the first derivative to be 0 and then we can find the value of the x to be x star. Fine. For example, you can see fx is given to this case. You have to find the error function, but error function at which point they are not given to you. That means x star is unknown to you. Fine. However, on this case, this is my fx. Fx is given as a sine of pi x, while your target is to find the error of the sine pi by 3. Can you find the value of the x? X is my 1 over 3. That means your target is to find the error at 1 over 3, which is nothing but my x star. So I will cover both kind of the examples in this lecture deeply. So let's start with the first examples. So before I just start with the first example, I request you kindly like the video and comment on it. First of all, remember students, your always first step is to write the value of the n from the given statement and write the value of the pi of x. Fine. How you write the pi of x? You can check about the points. There are the 2 points. The value of the pi is always be written in this manner: x minus x naught, x minus x1, x minus x2, and so on. Fine. How many points are there? This is the x0, this is the x1. So the value of the n is my 1. Fine. Or moreover, you can see it's a linear interpolation. N is my 1. Now finally you write the formula for the error. So what is the error formula is? It's a pi x divided by n plus 1 factorial. Now in this case, n is my 1. I can substitute here. What is the value of the ex? When n is 1, it is my pi x. 1 plus 1, 2 factorial is a 2. and it is my second derivative. Fine. Then we can find the maximum value, which is taken as less than equal to 1 over 2 factorial, maximum value of this. Again, you can see the value of the x star is not given. So firstly, I can find the value of derivative. What is the fx is? Log of x. Can you find the second derivative quickly? 1 over x. Second derivative is my minus 1 over x square. Then I can find the maximum value of this. Start from the 2 less than x, 2.1. These limits are taken from x0 to the largest point. Since we need the absolute value, it is 1 over x square. Can you find the maximum value of this? The maximum value is occurring at the when x is minimum, and x is minimum given as 2. So this number is my 1 over 4. Now, how you can find the pi of x? Pi is my given to be this. Since the point is not given, I can start with the first derivative to be 0. Can you find the first derivative? It is a 1 into x minus 2.1 into x minus 2 of 1. I use the product rule. So that becomes 2x minus 4.1 is equal to 0. The value of the x is come to be 2.05. Fine. So therefore, I can substitute this value at pi of 2.05 modulus. So that will be 2.05 minus of 2. That will be my 0.05 into minus 0.05. Now once you can multiply them, it will be 0.025 because it's a modulus, so negative value will be cancelled. Substitute both the values in this given equation, you will get the error bound as here. Fine. Now I will use the same concept throughout the remaining 14 examples. Look at that. Find the bound of the polynomials. What is the function fx is? It's a log of x. Fine. And since your target is to find the values error at 47, so the error bound is given to you 47. Firstly, you write the n and find the value of the pi x. How you find the value of the n? This point is my x0, this point is my x1, this point is x2, this is x3, this is x4, this is x5. So this 5, n is my 5. How you can find the pi? X minus x0, x minus x1, x minus x2, and the last number is x minus x5. Fine. So n is my 5. My truncation error is this case. Or you can write this maximum error is n is 5, 1 over 6 factorial. Because the value of the pi is given as a 45, so I can substitute this number is only 47. And this part is maximum of lowest number is my 40 up to largest number is my 50 of sixth derivative. Fine. Now let's start with the first derivative. Now what is the fx is? Log x. Can you find the first derivative? If f of x is my log of x, what is the first derivative? 1 over x into log of 10e. Can you find the second derivative? It will be, what is the second derivative is? Minus 1 over x square log of 10e. What is the third derivative? It is my 2 over x cube into ln and e. What is the fourth derivative? It is my minus 6 over x4 log of 10e. What is the fifth derivative is? 24 over x raised to power 5 log of 10e. And what is the sixth derivative of this? It's a 120 minus over x raised to power 6 ln of 10e. Fine. Or if you closely look about that, this 6 factorial, 6 I can written as a 3 factorial, this number I can written as a 4 factorial, this is written as a 5 factorial. Therefore, the maximum value of this number is my minus will be cancelled out, 5 factorial x raised to power 6 ln of 10e. When this number will be maximum? When this x will be minimum, and x minimum is my 40. So the answer is 5 factorial 40 raised to power 6 ln or log of 10 e. After the calculation you will get this number. Now your target is to find the value of the pi of 47. So what is a pi of 47? Pi minus 40 and so on. So can you find the number of the pi of 47? So this will be 47 minus 47, 5 is a 2. This is my minus 1. This is my minus of 2 and this is my minus 3. So because it's a modulus, so I can remove the negative sign. 5 into 2, 7, 7 into 5 into 2 into 1 into 3 is my. So I can substitute both the values in the given expression. You will get the right answers. Don't forget to like, subscribe and comment on the video. Again, your first target is to write the n and the pi of x. The given points are my 3. So I can write the pi directly, x minus 0, x minus 1 over 6, x minus half. This is my x0, x1, x2. So the n is my 2. In this case, what is my fx? Fx is my sine x and x is clearly x sine pi x and x is my, so your target is to find the values at the point 1 over 3. Fine. Now let's start with the error, because maximum error is n is my 2, so 1 over 3 factorial, because your if you compare them, x is my 1 over 3, so that means your target is to find the values directly at this and only this portion as a maximum of this one. Now can you find the derivative? It is my sine of pi x. Can you find the third derivative? The first derivative is pi, fine. Second derivative is minus pi square sine of pi x, and the third derivative is minus pi cube cos of pi x. Therefore, can you find the maximum value of 0 less than x of absolute value of the third derivative? So what is the absolute value of this is pi cube cos pi x, from x varies from 0 to half. Now clearly say this cos is my decreasing function, fine. So the maximum value is occurring at 0 because it's a decreasing, so it's occurring at the lower limit. So what is the value of the cos 0? Cos 0 is my 1. So this answer is my pi cube. Can you find the value of the pi 1 over 3? So clearly say I can start from here. So this is 1 over 3, or I can start with the modulus value. So 1 over 3 minus 1 over 6 into 1 over 3 minus, so it's a 1 over 108. So this answer is my pi cube. I can substitute all this answer. You will get the answer is 0.047849 is the right answer. Okay, look at this another case. Again, your target is to firstly write the value of the n and pi of x. There are the 3 points. N is my 2, x minus minus plus 1, x minus 0, x minus 1. Fine. I can substitute this value in the error bound. N is my 2, so it's a 3 factorial, and I can find the maximum value is, because your target is to find the maximum value error bound for this, but x star is not given to you. So that means you can write the maximum on the both cases. So firstly, for the function fx e raised to power 3x, I can find the third derivative. First derivative is 3 into e raised to power x. Second derivative is 9 into e raised to power 3x. And the third derivative is 27 e raised to power 3x. Can you find the maximum value from minus 1 to plus 1, absolute value of the third derivative? So which is equal to maximum value minus 1 to plus 1, 27 e of 3x. Now clearly say e raised to power 3x is my increasing function. Fine. Once is an increasing function, the maximum is occurring at the upper bound. upper bound is my 1. So it is 27 into e raised to power 3 is the answer of this case. Now, because x star is not given to you, so I can start with the pi x. Pi x is given to my this. I can open this bracket. What is the condition for the maxima? First derivative to be 0. So that number will be 3x square minus 1 is 0. That number becomes x is plus minus 1 over cube root. Fine, square root 1 over 3 square root, and both the numbers are lies between minus 1 to plus 1. So how you can find that? I can check the values. Firstly 1 over plus root 3, and second number is 1 over minus 1 over root 3. Fine, whichever is the maximum, I can substitute the answer at this point. So whenever pi x cube means 1 over 3 root 3 minus 1 over root 3. So if you take the LCM, it becomes 2 divided by 3 root 3. If you substitute here, it's a minus 1 over 3 root 3 minus minus plus. Fine. So again, it's a modulus value. So it is answer is same. So that means the answer of this case is 2 divided by 3 root 3. Answer of this is my 27 e cube into 1 by 6 is the right answer of this problem. Don't forget to like and comment on the video. Find the truncation error for the linear interpolation. N is my 1. Fine. When the step size is used, what is the meaning of the step size? That means if the first number is my xi, the next number will be xi plus 1. Or you can say if the first number is my x naught, next number will be x naught plus h. Fine. In the construction of the table. So I can use any of the 2 points for the linear interpolation, that is a xi and xi plus 1. Can you write the pi of x? X minus xi, x minus xi plus 1. So that xi plus 1 minus xi, that comes to be h. This is given to you as per this statement. Fine. Now can you find the error? So the maximum error will be 1 over 2 factorial, maximum value of pi x and maximum value of second derivative. Fine. Now because fx is my unknown to you, so I can simply take fx to be s number. So let's start with this case. I can simply take x minus xi divided by h, for example say y. So can you find the number of x minus xi plus 1? Can you find this number? So I can write for you here. I can add and subtract xi in this equation. Fine. What is the answer of this? X minus xi is my y of h. This number is my minus of h. So I can return this part is y minus 1 into h. I can substitute this expression. X minus xi is my yh. This number is y minus 1 into h. So therefore, your pi x becomes my pi of y, and here. What is the condition for the maxima? Maxima means the derivative should be 0. So that will be h square is outside. So it's my y square minus y. So can you find the derivative? 2y minus 1 is 0, and that will be y is my half. Fine. So I can substitute this value. What is the maximum value of the y of pi? I can substitute here. It is my 1 over 4 minus 1 over 2 into h square. That will be h square divided by 4. Fine. I can substitute this number. This number is my h square by 4. So that will be h square divided by 8. And dear student, you can remember this formula whenever it's a linear interpolation and the same step size used. याद बच्चों, ये फॉर्मूला काफ़ी इंपॉर्टेंट है अगर आपको स्टेटमेंट में लीनियर इंटरपोलेशन कहा गया है और स्टेप साइज के बारे में कहा। अगर स्टेप साइज सबका सेम है तो आप डायरेक्टली ये फॉर्मूला यूज कर सकते हो। ओके, लुक एट दिस वन मोर एग्जांपल। डिटरमाइन द एप्रोप्रिएट स्टेप साइज h, फाइंड लीनियर इंटरपोलेशंस। n is my 1, fine, n is my 1, fx is given to be this. Now you can see step size you have to target, so I can use the directly formula for this case. Fine. So linear interpolation n is 1 and the maximum error is for the linear interpolation is given to be this part, and in the given statement it is mentioned that it is bounded by 5 into 10 raised to power minus 5. So your target is only to find the second derivative. What is the first function is? Can you find the first derivative? 6 into 1 plus x raised to power 5. What is the second derivative is? 30 into 1 plus x raised to power 4. So therefore, can you find the maximum value from 0 to 1? Absolute value of the f double dash. Now clearly say this part is my increasing function. Fine. And once is increasing, so maximum value is occurring at the upper bound. So the answer is 30 into 1 plus 1 raised to power 4. That is 30 into 2 raised to power 4, 16. That is a 480. I can substitute this number of the 480 in the given expression and you will get here. Can you find the value of the h from this case? This number will be 8 into 5, 40 into 10 raised to power minus 5 divided by 480. And after the calculation, you will get this is the right answer. Find the bound on the error of the polynomial of degree less than 2. So your target is to find the value of the n and find the value of the pi xp. So what is the x naught? 0, x1, the x coordinate 1, x2, the x coordinate 3. So I can say n is my 2, the value of the x minus 0, x minus 1, x minus 3. Fine. Now you can write the interpolation error which is given as here. So n is my 2. So this error will be 2 plus 1 is a 3 factorial. Maximum value of pi x start from the 0 to 3 and maximum value of the third derivative. Now since the function fx is unknown to you, is the function is given to you? No. So I can simply assume the maximum value of this third derivative to be m, or because the third I can simply say m3 because the function is my unknown. Now my target is to find the value of the pi x. So pi x, I can open this bracket x into x square minus 4x plus 3, or again I can open that, it's a x cube minus 4x square plus 3x. Fine. What is the condition for the maxima? First derivative to be 0. So 3x square minus 8x plus 3 is equal to 0. Can you find the roots of the equation? Either you can use the calculator, or it's a minus b plus minus b square minus 4ac divided by 2 into a. After the calculation, you will get the two results as here. Now so you can see both the numbers are lies between 0 and 3. So your target is to find the value of pi 2.21525 and find the values at 0.45142. Fine. After computing the value, you can get the, because this is not taking the absolute value. If you take the absolute value, this number is my positive. If you take the absolute value, which one is the maximum? This is my maximum. So my answer of this case is, what is the answer of this number is 2.11261, and the answer of this is my m3, and that is the required answer of this problem. Look at this another case. A function is defined on the 0 to 1 which is approximated by the quadratic function The points are given to you. N is my 2. Can you define the pi function? X minus 0, x minus half, x minus 1. Again, you can see in this example, fx is my unknown. Fine. So we can define firstly error corresponding to n is equal to 2. But if you closely look about that, this part, the third derivative is less than 1. So I can say this is 1 over 6 factorial, maximum value of, fine, and the maximum value of this case is my less than 1. So I can simply write this case. Fine. How you can find this maximum value? I can simply say this number is my y is my x cube minus 3x square. How you can find the maximum value? First derivative to be 0. That is 3x square minus 3x plus half is equal to 0. Now you can find these roots. You will get the two equation. Either you can use by the calculator, or you can take the discriminant formula b square minus 4ac divided by 2 into a. Fine. After the calculation, you will get the two numbers, this one. And both the numbers are lies between 0 and 1. Therefore, you can calculate the value of the y at the point 0 points this category, and you can find the value of the y at this number. Fine. And look at which one is the maximum. Now you can see both the values are my same in terms of the absolute value. Fine. So I can substitute this value at my given point, and your answer is this one. Look at this another case. Find the maximum step size h, function linear interpolation. Fine. So again we can use the linear interpolation formula for the maximum error, and it is less than of this case. I think that's very simple. Now the only thing is you need to compute the second derivative. First derivative is e raised to power x itself. Second derivative is also e raised to power x itself. Then the maximum value from 0 to 1 of the second derivative. Now clearly say, if you write the maximum value from 0 to 1 e raised to power x, we all know e raised to power x is my increasing function. So the maximum is occurring at the upper bound. That answer is e. I can substitute this value as my e. So you will get the answer as h is less than of 0.03836. I hope student you can like and comment on the video as well. Find the bound on the truncation error. Function is given to you ln of x. What is the n? This number is x naught. This is x1. This is x2. So n is my 2. Can you define the pi x? X minus 2, x minus 2.5, x minus 3. Fine. And your target is to find the error at the particular point. So that means your x star is given to you 2.7. Fine. So you can find the value of pi directly at the point of 2.7. The only thing is you need to compute the value of the derivative. So can you find the third derivative? I think that's a very simple. It's a 1 over x. Second derivative is my minus 1 over x square. The third derivative is my 2 over x cube. Can you find the maximum value of this over the interval 2 to 3? Because 2 to 3 of third derivative absolute value, which is maximum 2 less than x is less than 3, 2 divided by x cube. Now when it will be the maximum, when x will be minimum and the minimum value is come as a 2, so that will be 2 divided by 2 raised to power 8. So 1 by 4 is the maximum point. Fine. Now how you can calculate the value of the 2.7? So I can substitute this 2.7 minus, it's a 0.7, 2.7 minus 2.5, and it's a minus 0.3. So that will be 642. This is my Fine. So I can substitute all these values in the given equations. You will get the right answer as 0.00175 is the right answer. Okay, look at this another case. Function is given. Again, your target is to find the error. You can define the value of the x, pi x and the n. N is my 2, x minus 0, x minus pi by 4, x minus pi over 2. And your target is to find the values at pi by 6. So x star is already given to you. That means your target is to find only the maximum value of the f double dash. There is no need. What is f? F is my sine x. So what is the first derivative? Cos x. Second derivative minus sine x. Third derivative minus cos x. So therefore your target is to find the maximum values from 0 to pi by 2 of the third derivative in the absolute form. So that will be maximum 0, x lies from 0 to pi by 2 and its absolute value is my cos x. Fine. And we all know cos x is my decreasing function, and once is a decreasing function, the maximum value is occurring at the lower limit. So cos 0 is my 1. So this answer is my 1. And you can find the value of the pi by 6. So that will be pi over 6 minus pi over 4. You can take also the modulus value into pi over 6 minus pi over 2. After substituting the value, you will get this is the right answer. Okay, look at this another one. In the computer program, quick access to the function fx, which is given as a 2 raised to power x, x belongs to the 0, 1. A table with the step size h is stored and the function are calculated. Calculate the maximum step size h so that we will get the error by the linear interpolation. Linear interpolation means n is equal to 1, and what is the maximum error we have seen is this case. Now, since we need to correct the result up to the 5 decimal places, fine, and we already discussed in our previous lectures where we have defined the error analysis. What is the error up to the n decimal places? Error is my half into 10 raised to power minus n, where this n is my number of the decimal places, and in this particular example n is my 5. So I can simply choose. Remember student, this n is not my polynomial. Fine, this is my decimal places and we need the 5 decimal places. So I can say half 10 raised to power minus 5. So that means your target is only to compute the second derivative of the function 2 raised to power x. Can you find the first derivative? 2 raised to power x into ln of 2. Second derivative is 2 raised to power x ln of 2 square. Can you find the maximum value of this? From 0 to 1, absolute value of the second derivative. So you can see easily this function, that is a 2 raised to power x ln of 2, because ln of 2 is my constant part, 2 raised to power x is my increasing function. Fine, and once is an increasing function, maximum is occurring at the upper bound. So the answer is 2 raised to power 1 ln of 2 square. So I can substitute this value here and you can calculate the value of the h. So I think that's very simple. Now you can calculate the value of the h by using this result. You can see that it's a very simple approach. You can solve all these error analysis, but make sure you have to follow this numerical analysis playlist so that you can get all these theory lectures with the help of the several examples in an easiest manner. You can also see we have discussed the trapezoidal, Simpson and other methods as well. We will discuss the error analysis in the composite Simpson rule in our next lecture. Till then, you can follow my YouTube channel. I hope you can like, share and comment on this video. don't forget to subscribe my YouTube channel. Thanks for the watchings. Thanks for the support. Best wishes always.